Hello everyone, so in this session we shall going to learn about data modeling. So data modeling is one of the most critical part in any BI or data analytics project. So before you build any dashboard in Power BI or Tableau or whichever tool that is in the industry, you first of all need to understand this critical step, that is data modeling. So data modeling basically will decide whether your project will succeed or not. So any dashboard that you see in the industry, just know it starts from this very critical step, that is data modeling. So what is this data modeling? That's one of the most question a lot of beginners they've been asking me. So in this session I'm going to tackle this critical step. So let's assume in a supermarket. In a supermarket, people buy things, money is paid, products are being scanned, and so on. So all this data is normally stored into a database system, into a data, let's say, storage system. So let's say, for example, this data can be stored into these relational database systems such as PostgreSQL, MySQL, SQL Server, and so on. So let's assume here we have this one. We have, let's assume these are our let's call this cashier of our supermarket. So these are cashier. Yes, so this so these are our cashier. So these are cashier. So cashier. So this cashier, they use, let's say, applications. So let's say they use application. Let's say they use application here. They use application to insert data, apps, or let's say machine. So this cashier, they use machine to so they use machine to so they use machine to insert data into this. So they use this machine. So they use machine here. They use this machine, and this machine, all this data is put into a database. Is put into a database. So let's call this database. Let's just write it db. So all these cashier, they use machine and they do the transaction, and all these transactions are put, all the transactional data are put into these, are stored into these database. So you see this cashier, they use the machines like the machine that they use to do the inputs of the transaction, And this transactional data, they're stored into a database storage system. So most of this data that is stored into this database system, most of this data is normally, there's no structure most of the time. Most of the time this data is normally, there's no structure. So most of this data, most of them is raw. Most of them is raw data, no structure, not structured. Not structured. Also, most of the time they don't have, most of the time they're very messy, and so on. So you find that all these raw data, not structured, messy data, they are being stored into this database system. But the problem with that is that when, for example, you want to extract a useful information from this database, now the problem comes in, because you will spend most of the time trying to understand this data. You are trying to figuring out, try to think about the, let's say, the data set, the data structure. So you'll find most of the time you are spending more time understanding the data more than even answering the question. So data modeling now is where now the data modeling concept now is where it comes as a solution for this. So data modeling is now the approach of converting. So the approach of converting this, the approach of now converting this into, so the approach of converting this into now structured format. So now we converting this into structured format. Let's say structured format. Structured format. So this process of converting this raw data into structured format is what we call data modeling. The process of converting, or the approach of converting all this raw data into structured format is what we call data modeling. So data modeling just sit between these. Data modeling. So this process is what we call data modeling. Data modeling. Yeah, so this process of converting the raw and structured data into structured format is what now we call data modeling. So data modeling is like is like it's like you have it's like arranging your own house. So let's assume this is your house. So it's like you are arranging your own house. So let's say your house is not well arranged. Let's say not well arranged. Not well arranged. So if it's not well arranged, so let's say for example, you have, let's say maybe your towel is in, let's say bed, towel is in bed, maybe let's say pillow is in, let's say kitchen, and let's say plates, they are in bathroom, plates they are in bathroom, plates they are in bathroom. So you see, like a towel is not supposed to be in bed, pillow is not supposed to be in kitchen, plates is not supposed to be in bathroom. So you will have to arrange these items into their respective location. So let's say now well arranged. So now if we arrange this item into their respective location, for example, towel will be supposed to be in, let's say towel maybe is supposed to be in bathroom, and let's say pillow should be in, maybe pillow should be in bed, and plates should be in, let's say kitchen. So you see that we have arranged this item. At first they were scattered all over the house. So you'll find most of the time it's even very difficult for you maybe to find, let's say for example, if you want to find a towel into this not well arranged house, you'll find it very difficult for you to find this particular towel. But for this well arranged house now, since everything is put into their required position, therefore it's even easy for you to find the item in the appropriate, let's say, location. So this process of organizing the messy information properly so that it makes sense and can be used easily, so this is basically the true picture of data modeling. So in data modeling now is where, let's say now you have, let's use the example of supermarket. So we have supermarket. So supermarket, we are dealing with customer buying, and then we are dealing with products, we are dealing with orders, and then we are dealing with transaction. So we are dealing with, let's say customer. So let's say customers, and also we are dealing with we are dealing with orders, and let's say we are dealing with we are also dealing with products, and also we are dealing with, let's say the time, or that order. We are also dealing with different, let's say, order dates. Order dates, let's say order dates. So you'll find most of the time these items, they've been put into a large table. So we have the table, the same table contains customer, the same table contains orders, the same table contains products, and the same table contains the details of the order dates were there. So it becomes very difficult when dealing with this kind of data in terms of even the query performance, the storage, also the data is not even well structured and so on. So that's where now the data modeling comes in. So data modeling now is where we shall going to place this item into their respective tables. So we're going to have different tables for these items. So let's just write tables. We're going to have different tables for these items. So therefore, we're going to extract the customer details from this main table, and then here we're going to have customer, let's say customer table, and then also we're going to extract the orders details from this main table, and then we're going to have orders, let's say orders table, and then we shall going also to extract the product details from this main table, and then we shall going to, let's just have products table for products, and then also we shall going to extract the this detail, where we're going to put to create a table specifically for the dates. So this table we normally call it calendar table, and then we can decide to have another table for transactional, dot table. Yeah. So in case, for example, I want to know the total revenue of customer, let's say customer C1. Let's say customer C1. So customer C1, the detail of customer C1 is in customer table, and the detail of revenue is in, the column of revenue is in this table, transactional. So for me, I'll simply going to join these two tables. The transactional table and the customer table, and then I'll get the customer C1 and the revenue of customer C1. So it's even, so if you look at it, it's even easy for you to get the right data from these arranged tables than if you just leave this data into this, let's say, less structured data. So let's say, for example, I want to know the total revenue of product, let's say P1. So column P1 is found in product table, and the revenue is found in transactional table. So I will simply going to write a simple query of joining these two tables, the table containing the P1, the table containing the P1, and the revenue. So you can see it's very fast when you do when you organize this data into these formats. So this whole process is what we call, this whole process of coming up with all these tables is what we call now data modeling. So let's just call it data modeling, the process of organizing our raw data. So this is our raw data, and we've organized it into tables so that we can use this data faster and also make our data easily accessible even to those people who don't understand the technical side of the business. So this whole process is what we call data modeling. So let's properly define what is data modeling. Yeah, so you can see, as we've seen on the example, that we have raw data, and then out of this raw data, we've come up with the tables. And in this table, we'll first of all going to define the structure of the tables, where there's, for example, the details for customer will come to customers, the details for sales will come for sale. We're going to create a sales table, and then the details for this one. All respective items fall into their respective tables. So by doing this, it will enable us to have the data quality, in terms of data quality. So here we have the data, we have the raw data, and here we have the model. So you can see the data model, we can see our data is well structured, and also the relationship are well defined, and also we ensure that there's a data consistency. So by building the model, you can see we're going to have a well-structured data, where the data is clean, where the data is very consistent, and this data is ready for analysis. So data modeling turns the messy data into structured and usable information. So data modeling can be defined as the process of organizing data in a way that makes sense, that in a way that it's easy to store, to connect, to analyze, and use for the business decision. As we've seen, the data is kind of scattered. We put the we define the table structure, we build the relationship among the table, and then we finally have a structured data. So this structured data, as you can see, it's very easy to store, and also very easy to connect, because we've defined the relationship among the tables. And this structured data, you can see, it's very easy to analyze and also very used for the business decision. So that's definitely the definition of data modeling. So data modeling, think of like designing a blueprint of a business data system before building the dashboard. Like, first of all, we design the data model so that we can come up with this well-structured data, and then this well-structured data now is where we can design a dashboard. So for example, in a supermarket, you can see customer places orders, and then orders contain products, and then products belong to category, and then payments are linked to the orders. So without structures, you can see the data can become very messy. As you can see, we have the customer details, we have the orders details, we have the products details, we have the payment details. So all these items, without well structure, you can see the data become very, very messy. So that's where the concept of data modeling comes in, so that we can create the relationship. For example, customer placing order, so that means there's a relationship between the customer and the orders. Orders containing products belong to category. So you can see there's a relationship among these entities. So data modeling creates the relationship between all these pieces, so that we can end up getting this well-structured data that we can pull it into Power BI or Tableau and try to analyze the business in the proper way. So here we have, so data modeling answers these three questions here. So the first question that answers is, what entities exist in your business? So entity that exists in your business. So for example, if it's let's say supermarket, there's different entity that this, like there's different things that this supermarket business needs to track. So for example, the supermarket, it has customers. So the customer are the one doing the orders, and then in this business, supermarket business, there's orders where the customer do the orders, and then we have products. So I think those are the items that example of a supermarket business you can have. So we can track so let's say let's just move this. Yeah, so the entity in this, so the entities in, let's say, supermarket, let's just call it that way. So the entity, the thing this business can track are the customers, and then two also deals with the products. the products these supermarkets they're selling. It also deals with orders and so on. So these are some of the entity that a business like a supermarket have. So that's first question that data modeling answers. Because when we are creating this, so let's say for example we have the large table. So for us to create these tables you're seeing, the customer, the order, the products, and so on, first of all we need to understand the entity of the business. So this entity will give us now the table. So for example, our entity in supermarket is customer. That means if we have a large table here, let's say a large table here, that means we will have a table. We will extract a table from this large table, and we're going to create a customer table. So this customer table will contain all the details related to customer. And then from this large table also, with the help of this entity, we can extract the details of all products from here. We can extract the details of all products. And then from this large, so let's say a row table, we can also extract the orders the details of all orders into a specific order table. So that means we will have customer table, and then you have products table, and then that means we'll going to have orders so here we're going to have order table, and here we're going to have customer table. So you can see from this raw data we have come up with these tables. So we've generated these tables. So therefore, when we are doing data modeling, first of all we need to identify the entity. So this entity are the one that will going to give us the table. So that was the first question. Next question now is, what attributes describe those entity? As you have seen that, for example, customer table. So customer table, so the attributes means the column of these tables. So the column of customer table, for example, we can have something like customer ID, maybe customer ID, customer name, something like this. Same to products. Here we're going to have something like product ID. Maybe product name. Maybe category, product category, and then order also, maybe order ID, maybe order date, So we will have defined the attributes of these tables. So this is for order. This is for the table for products, and this is the table for customer. So first of all, we've defined the entities where we're going to say customer, the supermarket business deals with the customers, and so that means we're going to have customer table, products table, and orders table. And within those table is where we need now to define the columns or the attributes. So for example, for customer, we are going to have customer ID, and then we are going to have customer name, all those kind of things. All the columns that are relevant to, let's say, customer. And then for products, we shall also going to define all the columns that are relevant to products, and same to orders. So that's that's second question. So for example, a customer has a name, email, city, and so forth. So these are the columns related to customer table. And then you have orders, can have order date, total amount, maybe status, and so forth. So all these are kind of column for the order table. Another question that data modeling answers is, how do those entities relate to each other? How do those entities relate to each other? So after we've defined this entity, so this entity, they normally relate to each other. So for example, a customer places many order. So a single customer, for example, I can go to supermarket and place as many order as I want. And then an order can contain many products. So let's say I can order one single, let's say, transaction. I can order many products, and the products belong to one category. So how do these things connect? So you'll have to understand how this entity, they connect to each other. So the answer to these three questions now become your tables. Yeah, your tables. So this one is the tables, the columns, and then the keys. Now the keys is where now we shall going to get the primary key and the foreign key. So for example, if it's a customer order, how does it connect with the orders table? The customer table, how does it connect with the orders table? So that means there'll be a primary key and a foreign key. So that means these two columns, for them to connect, these two tables, for them to connect, that means there must be a common column between these two tables. So that means one of the column will have primary key, and the other column, the other table's column will have foreign key. So if you get them, if you get all this data modeling right, your data warehouse practically queries itself. And then, but if you get this data modeling, the whole of it, wrong, therefore the data analyst, the data scientists on your team will end up fighting with the data instead of using this particular data. So I think that one is very clear. So now we need to understand, why does data modeling matter? Why do we need to create all these coming up with all these tables? So why does really data modeling matters. So here is a simple summary of why data modeling really matters. So first of all, a bad model, it will have chaos. Also, a bad model, it will have higher cost, and also it will have slow performance. Therefore, slow performance in a way that we'll have to, the query performance, for example, if you're pulling data, if you're writing your query, it might take more time to be executed when the model is not good. And then we have the good model. So this good model, we have clarity. We can see the customers table, we can see the sales table, you can clearly see the, let's say, orders table and so forth. And also there's efficiency, and also there's it is also scalable and so forth. So these are some of the impact of having a good data model. So one of them is reduce cost and errors. So this, if you build a bad system, fixing it later is very expensive. So that one is very straightforward. And then we have improve system performance. So you can see, if you have a good data model, therefore if you write, when you are writing your query, you will see your query will be executed faster than when you have bad data model. And then it bridges the tech business gap. Yeah, because for example, after we have our structured data, even the person who doesn't really have the technical background, he can see this is a customer table, this is a product table, this is a sales table, this is a date table. So it reduces it bridges the tech business gap. So with data modeling, everyone understands this is customer, this is sales table, this is, and so forth. So it all comes after we've done the right data modeling. And then it also ensures data quality and integrity. If the data is structured, that means there'll be is well structured. That means there'll be no duplicates, there'll be no missing values, the data will be consistent, and this generally will ensure the data quality and integrity is very high, and also powers the analytics and AI. As you know, AI and dashboard, these normally they depend on clean data. If your data is not clean, therefore that means the output or your dashboard will definitely not going to be clean. So AI and dashboard generally needs clean data. So if the data is messy, AI give wrong prediction, and also dashboard give wrong output. So this is the common mistake most of the company makes. So we have one of the biggest mistake in business intelligence is skipping the modeling step and just dumping the data straight into the data warehouse. So this might look fine at the first, and it might even work for the prototype and maybe early exploration. But the moment another person start querying that data is when everything starts to break. So without proper data modeling, you will end up with confusion, duplicates, conflicting results, and over time. So those inconsistency only multiply and become harder to fix. So generally, we just need a well good, a well-designed data model. We cannot afford to skip this critical part of data modeling. So I think up to this point, everything you've clearly understood this data modeling, and I hope you've enjoyed this lesson.